Now our last speaker for today will speak. Sagar Sonwane will speak about uncover unknown bugs with fuzzing in Go. He's the remote speaker. Please welcome him, Sagar Sonwane.
Hello everyone. Am I audible? Hello everyone. Good afternoon. I hope everyone is doing well and not sleepy yet. So today I'll be speaking about uncovering unknown bugs with fuzzing in Go. But before moving on with that, let me first introduce myself. So who am I? If you have seen this movie, you know that Jackie Chan's memory got fuzzed up, and for the entire movie he was trying to figure out who he was. But lucky for me, I remember who I am. So let me first introduce myself. My name is Sagar Sonwane and I am from India. I am passionate about building products that make a difference, and so far I have been involved in building application in security and fintech domain. I also like to write blogs and I contribute to open source in my free time. And when I'm not coding or writing, I like to watch some anime. For all the anime lovers out there, my favorite anime is One Piece. I have been working as a software engineer for past 2 years at Josh Software. Here, I am not talking about your friend Josh. Josh stands for passion and enthusiasm. We believe that programming is an art and we are the artists. We are one of the early adopters of Go in India and we enjoy organizing workshops, tech events and talks. We are proud organizers of GopherCon India for last 8 years. We provide solution to clientele all over the world since 2007. Do follow us on Twitter to know more. Now let's get started with the talk. Bug in my own backyard. When your application crashes on production because of some bug you are not able to catch on time. This hurts a lot, right? Something like that happened to me as well. So let me tell you what exactly happened. I am currently working on a security domain project which deals in providing secure zero trust access without relying on network centric solution like VPN. Our system architecture is quite complicated, but for today I'll stick to this small part which is relevant for now. Here we have a REST API server and one auth server, where both services use MySQL DB and PostgreSDB respectively. So one not so fine day, one of our pen tester decided to try something out and he made an API call to the REST API server with a null character in the request body. Now REST API starts to process the data and saves in MySQL DB, then passes it on to the auth service through WebSocket for further processing. But the thing with Postgres database is it doesn't allow storing null characters in it, which in turn failed the process. And now if this had effect only on that API call, this would not have been a big problem. But that was not the case at that time. This so small looking issue totally screwed up syncing of all other components of our stack with the auth service. Yeah, so this was it. We had to face a lot of embarrassment at that time because of a simple null character we missed to test against our API. And let me tell you something. If we had first tested our API, this bug would have been caught within a matter of seconds. But we didn't, as I didn't know anything about first testing at that time. Now let's keep this aside and move on to some another problem which my friend Ross had to face. So meet my friend Ross. He's a fellow gopher and he likes to code. So one day Ross gets a task to write a reverse function. Very easy, right? And Ross thinks the same. He thought, this is so easy. I can write this in my sleep. Just look at him. So smug, not even looking at his screen. So this is what he wrote. The reverse function which accepts a string, converts it into a byte slice and perform byte swapping since string is nothing but a byte slice only, and returns the reverse string. I don't see any problem in this right now. Do you? But let's move on for now. Just to be sure that his code works properly, Ross also wrote the test cases. And the test cases he wrote were good enough as well. I think this covers everything, right? A simple hello world string, an empty string, and with some numerics and special characters. Looks good to me. Now the test cases pass and Ross's code get merged and released. He's so happy and chilling right now. But something happens. Over the weekend, something bad happened. Ah, the application crashed because of an edge case they missed. Ross is so furious right now. He's thinking, how can his code even break? He manually did the testing, he wrote the test cases, everything passed, but still his program failed. Why? How can this happen? And now Ross starts debugging the application logs in search of the bug. He found out that someone passed €1,000 as a string input and the reverse looked something like 0001 question mark question mark. So what is this? What exactly happened here? So here the input string contains a euro symbol, which is a Unicode character and takes more than 1 byte to store the value. And since strings are nothing but stream of bytes only, so when Ross's reverse function worked, it tried to reverse the string byte by byte, and this failed the reverse operation. So here Ross missed an edge case, right? He didn't consider having special Unicode characters in a string. So this was eventually gonna fail. Now the thing is, Ross neither wants his code to fail because who likes a failing code and that too on production? Nor he wants to write million test cases for every program he writes. He'd prefer shooting himself over doing that. He is thinking that if someone could write all the test cases for him, that would be so awesome, right? I also think of same sometimes. But not knowing what to do now, Ross goes to Sagar and asks for his help. So don't forget, that's me. From my past experience of having an application crashed on production because of a similar thing, I know exactly what Ross is looking for. So I told him about something called fuzz testing, which can help him find bugs in his application and could also save him time writing a ton of test cases. Now Ross wants to know what exactly this fuzzing or fuzz testing thing is because he has never heard of this before. So let me tell you, fuzzing is a type of automated testing which continuously manipulates input to a program to discover coding errors and security loopholes. So instead of testing with a small predefined set of test cases that are handwritten by developers like unit test, fuzz testing constantly tests your code with newly generated inputs. And using the feedback and result it gathers, it generates additional test cases in an effort to explore all of your code's application path. This feedback loop is running thousands of times per second, making it an effective way to test your application very thoroughly. And with the latest Go 1.18 version release, languages started supporting fuzz testing in its standard toolchain, allowing developers to write fuzz test just like we do for simple unit test cases or benchmarks. But this doesn't mean there were no fuzz testing tools before there. There were, and one of them is Go Fuzz by Dmitry Vyakov, and it is very popular. He used his Go Fuzz library to fuzz test Go language repository and find a lot of bugs as well. And I think that probably made the case for introducing fuzz testing in standard toolchain as well, right? Ross now wants to know how can he perform fuzz testing on his reverse function. He thinks if there is one bug which he didn't know existed, there could be a possibility of having more bugs, right? So let's look at how fuzz testing is done in Go programming language. There are few rules that need to be followed in order to perform fuzz testing. The naming convention followed to write a first test is the function name should start with first keyword followed by the function name. So if I want to first test a reverse function, I would probably give it name fuzz reverse. It should accept testing.f argument and has no return arguments. And all the tests should be written in underscore test files. So all three of them look familiar, right? This is what we do for unit test and benchmarks as well. We write unit test by naming it as test and whatever function name we want to test, and pass a testing.t object. So similar what we are doing for first testing. But there are two important things we define while writing first test. First is we add entries to seed corpus using an add method on testing.f object, and we write a first target using fuzz method. So now let's try and test Ross's reverse function to check if fuzzing really works. So let's move on to the demo and see. Now let's first test the reverse function which was written by Ross. This function will accept a string. It will convert it into a byte slice. It will loop over it one byte at a time and return the reverse string at the end. And we have a main function here which has a string literal welcome to GoLab conference, and it is reversing a bunch of times. And we have this reverse underscore test.go file which has the unit tests which were written by Ross for this reverse function. So first what we will do is we'll just run all this and try to verify if this code is working properly or not. So as I run the reverse.go file, I can see three lines. First is the original input which was given to the reverse function, that is welcome to GoLab conference. Then we got a reverse string, and again we reverse the reverse string to get the original one back. So if original and double reverse is same, that means the reverse function was working properly. And just to be sure, we'll run the test cases as well. So yeah, test cases also works. So now, since the test cases and everything is passing, we should go ahead and write first test for our function. The thing is, the unit test has a limitation that each input must be added to the test by the developer, whereas fuzzing comes up with its input for your code on its own and may identify edge cases that unit test didn't reach. So in some previous slides, we just saw rules to implement first testing. So let's try to write a first test for our reverse function. Though I have already written a first test here, let me walk you through what are the components which a reverse test has. So first thing which we declare is a first test, and the naming convention we follow is to start the function name with fuzz, which takes a testing.f object as an argument. So this naming convention is very much similar to what we have for unit test, that is test and whatever function name we want, and for benchmark test as well, that is bench and the function name. Now we add some entries into the seed corpus, and for that we will use the test inputs which we had in our unit test case. So that hello world, empty string, and special character 1 2 3 4 5 string. So we will use this as seed corpus entries to our first test. But what is a seed corpus? So seed corpus is basically a user provided corpus for a first test which can be used to guide the fuzzing engine. So it is composed of corpus entries provided by f.add function calls within the first test. So basically whatever we are adding with the help of this f.add, it will be added to our seed corpus entries, and the fuzzing engine will use this to generate further entries to test our first target. Now we will write a first target. So first target is a function of first test, which is executed for corpus entries, and generated values while fuzzing are tested against this first target only. And the seed corpus entries must have identical types to fuzzing argument, and that too in same order. So here we are writing a first target, right? And we are passing the first parameter as testing.t. But the other parameters here are the fuzzing arguments. And the order and type of the fuzzing argument should be same as the order and type for arguments we pass to f.add, that is seed corpus entries. And even though like this syntax is very easy, but fuzzing has a limitation that in your unit test you could predict the expected output. Like we had a reverse function, so if I am going to provide it an input of 1 2 3 4 5, I know I'm going to get 5 4 3 2 1 and verify if unit test is actually meeting those expectations. But you don't know what input your fuzz engine will give to your first test, so you cannot predict what will be the output. However, there are few properties of a reverse function that you can verify in your first test. First one is reversing a string twice preserve the original value. So if I have a string 1 2 3 4 5 and I am reversing it twice, that means 1 2 3 4 5 to 5 4 3 2 1, and then again back to 1 2 3 4 5. So the first and last value should match. And the second thing is reversed string should be a valid UTF-8 string. So for those two conditions, we have added our code here that if the original string doesn't match the double reverse string, return an error and crash the application. And for the second thing, that if the input string is a valid UTF-8 string, but the reverse is not, so then also raise an error that reverse produce invalid UTF-8 string. Now let's test with go test command. So I'll just run this go test command. Okay, I don't think I commented my unit test, so I'll just comment my unit test first. So what will happen is if I comment my unit test, it is not like mandatory to comment your unit test, but just for the sake of demonstration, I am commenting it so that you can see that if I run just go test command, the first test which I have will run as unit test only. First test -v. So you can see that it is running the first test with the seed corpus entries. So if I want to generate random entries at runtime to test my function against, so I need to give this flag -fuzz and give the function name. So this will start the process of fuzzing, and it will start giving my reverse function multiple set of inputs to try out, and it will look for crashes and probable bugs. So as I run the command, you can see within a second it was able to find a bug within this code. So if you can see that there is a lot of information given on the terminal right now, so we won't go into this starting ones. We will look at them later, but we will stick to these two for now. So the first thing which we have is that our test case failed, and here it failed because reverse produced invalid UTF-8 string. So there must be a string which was given to our reverse function, which in turn created a reverse of it, and that reverse string was an invalid UTF-8 string. So that failed our program, and the failing input was written into a file. So it is giving that the input string is stored in test data /fuzz reverse at this hash. So if you go to your project directory, you will see that there is a test data named folder there, and inside it there is a file, and you can see that there is something here. So this may look like double quotes, but it is not. There it is a special character. There is something down under the quote here as well. So this is not just a simple string. So the first line of the corpus file indicate the encoding version. This fuzzing engine needs sometimes to verify what kind of encoding version we are using. For now, it is version 1 only. Maybe other versions will come later on. And following the encoding version, the line represents the value of each type making up the corpus entry. So since our first target takes only one input, there is only one value after the version, and that is the string which failed our program. So now let's go back to our logs and look at what failed exactly. And from the logs, we realize that the reverse string was an invalid UTF-8 string. So what does it mean to be a valid UTF-8 string? So it means that the string should consist of valid UTF-8 encoded runes. So here lies the problem. The current reverse function reverses the string byte by byte, and we are expecting the string to have valid UTF-8 encoded runes. So since our reverse function is dealing in bytes, it is like, in order to preserve the UTF-8 encoded runes of our original string, we must instead reverse the string rune by rune instead of byte by byte. So let's first debug our program to see what is happening. So I have a logger call here, which will just print the number of runes in original string, the reverse string, and the doubly reverse string. So let me just run it again. Go test will also do, I guess. Yeah, but it is running all the things. But still, we got to know that this is information that we needed, that the original string had one rune, whereas the reversed had two, and the doubly reversed had one. So the entire seed corpus used string in which every character was a single byte. However, the one which we have right now in the corpus entry here is, it requires several bytes to store this character. So thus reversing the string byte by byte will invalidate multi-byte characters. So let's fix the program, and what we will do is we will just change this type from byte to rune. So this should fix the program. Let's try to run the go test command. And yes, the test cases are passing now. It is fixed. Nice, the bug is resolved. So now let's run the go first command again. Yeah. So it failed for some another character as well. So let's look at the logs, and it is showing that before string and after string. So that means it failed in our initial condition of the test. That means the original string and doubly reverse string did not match. So let's see for what corpus entry it didn't run properly, and that is this string. So this is an invalid UTF-8 character. So strings, since string is a read-only byte slice, it can contain invalid UTF-8 characters. So first let's try to debug the problem, and then we will see how to fix it. So I'll just comment this one out. because I have a reverse function down here which has some print statements. So I just added two print statements here. First is printing the input value, and it is printing the rune conversion of that string. And we will get the path of this to run. Oh, so it ran for all the. Let me just run it for only our test case. Yeah, it is showing that the input which was given was this string, and then it was converted into a rune character, which is this question mark within this diamond stuff. And then again, when we try to double reverse it, so this was the input, and it reversed it back to this diamond question mark only. It didn't get reversed back to this. So this is where the problem is in our code right now. So we will need to add a check in our program to check for invalid UTF-8 string as an input and return if an error is found, because this is also causing problem with our function, that if there is an invalid UTF-8 character in our string, that makes the logic haywire. So what we will do is we will just comment this function out for now. We will uncomment this one and we will make fixes here, that if the input string is not a valid UTF-8 string, then return empty string and an error with a message that invalid UTF-8 character. I need to add return parameters here as well. And need to send here. And just to make sure we catch the error value everywhere, for now I am just using underscore in the main function, because the important part where we need to handle error is our test case here. So I'll just add error handling here, and we will return. And same thing I'll do for here as well for our second conversion, that is doubly. And we will try to run it again. So it passed now. It has been fixed. And if I try to run the test, tests are also passing for both the seed corpus entries, all the three seed corpus entries and the other two corpus entries which got generated later on, which potentially find a bug in our reverse function. So again, if I run my fuzz function, let's see if it is able to find anything more into it. So yeah, I think it is working fine now, since it has been 9-10 seconds and it was not able to find anything, and it has run over 1.5 lakhs entries against our function. So that is a huge count, right? So the elapsed time here shows the time first test has been running. Number of execution means number of inputs which are tested against our function. And this new interesting means that it had found some new corpus entries which discovered some other branch in our program. So the thing is, Fuzz engine wants to increase coverage more and more, and that's why it wants some corpus entries which explores new branches. So whenever a corpus entry hits a new branch, it consider it as a new interesting. So that's what we are talking about here. And if I want to stop the first testing, I will kill the process, Control C, and yes, all the test cases are passed. You can also set a timer to it, like you can perform first testing for a limited period of time, like 10 seconds, 20 seconds. So there is also a first time named flag there. And the third reason for first test to stop is it will crash. So yeah, this was all about the demo for first testing. Ross's mind was blown when he saw that first testing was able to find out all the bugs in his code, and that too within seconds. And he thought, this is crazy stuff, man. And it was so easy to do. He had to just try and write few lines of code to test all of his application. And it was able to find out all the bugs in it, and his code is bug free now. He's thinking, why didn't he find anything like this before? So powerful, right? So let's just do a quick recap of what we just saw in the demo. This is what a basic first test look like. It has 4 components. First is the first test itself. Then we add some entries to seed corpus to direct the fuzzer. Then we have a first target, which is run continuously against generated corpus entries. And we have some fuzzing argument, which are randomly generated by the fuzzing engine. And there are 2 ways to run a first test. First is when we just run the go test command, it will run the first test as normal unit test against the seed corpus entries we have. It kind of acts like regression. And the second way to run a first test is with -fuzz flag, which allows fuzzing engine to generate random inputs to test your function. So this is what we saw when we run this go test -fuzz command. This is the information provided by fuzzing engine. So when you run the first test, this is what it looks like. It shows us the number of executions. It shows new interesting time elapsed. And this is the information Fuzz engine provides during its active execution. And here we saw the failing part of the first test and some error logs. So it was able to help us find what went wrong with our function while testing. And obviously the failing inputs are saved in the seed corpus to just make sure you know what needs to be fixed in your application. So let's say you have a failing input in seed corpus entry and you decided not to fix it. And then if you push the code and there is a test pipeline setup, then it's going to make sure that pipeline fails since you have not fixed the code for failing input. So fix it. It is going to help you at the end. From what we just saw, it kind of looks perfect, right? But there are some limitations to it for now. The first one being you can only write a single first target in a first test. So if you try to write more than one, it will not allow you to run the test. And the second one being it only supports primitive types for now. Like Fuzz engine is only able to randomly generate input for the primitive types like string, byte, int, float, etc. Hopefully it may provide support for different types as well in future. So till now we saw how to write first test and how it finds bug and its limitation. But also let's look at how fuzzing internally works. So as we can see in the image, there is a fuzzing engine running continuously when you run the first test. And the fuzzer is sending inputs to the application and using the coverage generated by that input. It guides the next set of input to discover any new branch in the code until it is able to hit a branch of code that causes the bug. And this is what we call coverage guided fuzzing. So if, let's say, I send an input string AA, and it was able to hit a new branch because of that input, so it will generate new entries around that AA string only, so that it could go deeper into your application code. So extend our little example problem to 1,000-line code path in a critical application, and a fuzzer churning through billions of input can take only few minutes to discover subtle bugs that would otherwise take days to unravel in production. So this is how powerful fuzz testing is. Now let's look at how fuzz tests differentiate from unit test. Let's understand with the help of an example. Let's take the example of a program for a maze. And let's pretend we have a robot up there at the top, and the input to the program we are going to give are the direction to the robot through the maze. So let's take an example that input down, left, down, right, and bunch of downs is going to take that robot to some end. And now robot is going to follow the instructions through the maze, and we see that there is a bug down there. We actually verify it and resolve it. You can think of this as how unit test works. We instruct computer to look into our program at certain places for bugs. But the thing is, our program is a maze. There are a lot of places which could go undiscovered and could have other potential bugs which we didn't think of exploring. So this is where fuzzing comes into picture. Fuzzing by itself comes with the input and tries to find all possible paths in our maze-like program. So we don't have to provide input to a fuzz test. It on its own try to generate input and explore more and more of your code. It tests with random set of input without any assumption and tries your program against all kind of random inputs. And since it is not a person who is like writing the inputs, but a computer is, so it is able to like run thousands of input in matter of seconds. So after looking all the cases before, I think there were some obvious reasons we would need fuzzing, and the most spoken one being the missing edge cases, because you don't know what you don't know. As we saw, a lot of missing cases were there in our programs, and generally we forget to like test for missing edge cases. And first testing does not run under any assumption. It tests for anything and everything. When you write unit test, you generally set some expectation and you try to find out if those expectations are met or not. But when fuzzing works, it does not have any expectation in mind. It tries to give any set of input and try to check if your function is working for all of them. Fuzzing can identify bug which unit test cannot, like crashes, hangs, etc. And if you don't fuzz your code, some attacker might do it for you, and that will not be good. So now the question is, what to fuzz? Probably anything that takes an input. Try fuzzing it, and I'm sure you will find something. If your program has any publicly exposed API, you better first test it, because if you don't, someone will try to do it and that is not going to be good for you. And if you have an embedded software or IoT application that receives a lot of data from sensors and unknown sources, so you better be sure that nothing breaks your program. And some libraries for encryption, cryptographic libraries, parser, etc. are all good examples of programs that can be fuzzed. General problems with your code that fuzzing can identify. The average Go API in production is significantly more complex than simple example of a reverse function we saw. So making it even more likely that issues like unhandled error, logical bugs go undetected. And some problems like timeouts, hangs can also be detected by fuzz testing, which general unit testing cannot. So who can fuzz? Can only the pen tester who was able to find bug in my code by sending that null character do fuzz testing? No, anyone can fuzz. You don't need to be a security expert or hacker to perform fuzzing, and you already saw how simple it is to do that. So just fuzz it, you will see the magic. Let's look at some tips to make sure you write fuzzable code. Writing testable code means that even the smallest components are independently verifiable. So if your code is hard to even unit test, then it will be hard for you to first test it. First target should not depend on global state. It should only depends on the fuzzing arguments which you are going to provide. And have your main logic as separate modular entity so that it will be easy for you to set up first test against. And I think this question might have come up in someone's mind by now that can we continuously first test our application? So let me tell you, it is possible. The OSS Fuzz is a Google's continuous fuzzing service and it is freely available for open source software. And along with that, there are few other paid tools which can be useful for continuous fuzzing of your applications. So the more you fuzz, the more bugs you will be able to identify. And as of May 2022, OSS Fuzz was able to find around 29,000 bugs in Chrome, as well as 36,000 plus bugs in over 500 open source libraries. So the stats speaks for themselves. It is effective. And the bugs which we found in our reverse function were found within seconds. But sometimes finding bugs can take a lot of time because fuzzing engine need to go through a lot of code if it is testing your whole software. So a bug in OpenSSL was identified after 1.5 years of continuous fuzzing. So you may think it takes time, but it is effective. And in most of the cases, it will find bugs in your program in first 10-20 seconds only. So when in doubt, just fuzz a bit. You will find something. Thank you for listening to me. That really means a lot. Thank you. Any questions?
Am I audible? Just wanted to give a quick shout out to Roberto Clapis here. Some of the points I mentioned in the talk were inspired by one of his talk on practical fuzzing. So yeah, I think we are open for questions. If you guys have any questions, please ask.
Thanks. I noticed that for inputs that we decide are invalid, we just return early from the function. Do you know if is that like something? Is there a way to train it in progress in the future of Go, or basically if we just return if we decide that the input was not valid for us? In your example, for example, you got an error and you just return.
Actually, the thing is, you will have to identify some invariants your code. Like for the reverse function, we identified few properties that those should hold true. Like the double reverse should be same, and the reverse string should be valid UTF-8 string. So it's all about identifying some invariants which hold true for your code, and you will have to write first test around those conditions. So if the expectations are met for that, that means your like first test is working. Otherwise, if the expectation are not met, you can like say that your program is not working properly. So yeah. Actually, the thing is, first testing is kind of limited right now. And since when we write unit test, we are the only ones who are setting the expectations. We are like giving the expected output for a certain set of inputs. But in case of first testing, we don't know what inputs are going to be for our function. So in that case, we'll have to identify the properties which should hold true for our use case, and around that only we write the test.
Hello. I have a question about how to fuzz when you don't have an invariant property or a property that you can exploit to verify if the result of the fuzz is correct or not. Do you have any suggestion when you want to test a function, when you want to fuzz a function, when where you don't know a property that you can exploit to see the results?
So if you don't know what your invariants are in your program, you can basically just directly first test it. Because the thing is, invariants are there to identify logical or behavioral bugs. But even if you don't set some expectation for invariants, you can still find out crashes or some other bugs like timeouts and hangs. So that are still possible even if you don't set any condition around your invariants. I hope this answers your question.
If there are no other questions, I guess this is a wrap. Thank you, Sagar, and thank you all for coming to GoLab 2022, and we'll see you again next year.
Thanks, everyone.